Given a graph, and we're asked to find the numbers at which f of x has a relative max. There is only one relative max, and the answer is -3. At x equals -3, there is a relative max. What are the relative maxima, which is plural, but there is only one, and the relative max is 3. I'm sorry?
Never mind. I see it.
The numbers for a relative minimum, there are two relative minimum. One appears to be at -4 and the other one at -2. And what is the value of the minima is -1. Okay, and that's pretty much it. So the relative max is, and the numbers are, so all this really doesn't make any sense. So this one shouldn't even, I wouldn't even look at it myself. I will just answer part A and part B, and I will move on to the next problem. Okay? Anything else? Anything else? You need some paper? You need something to write on? No? Okay, here it is. Okay, good. So let's start. Any other questions? Did you have anything else? That was it? Oh, okay. Very good. My pleasure. So let's go and practice the difference quotient. One function is not good enough. So we are still in section 2.2. Let's choose, let's say, 80 on page 252. So f of x equals 3x squared plus x plus 5. We're asked to find and simplify the difference quotient. So we know that the difference quotient is f of x plus h minus f of x divided by h. Again, this is fixed, no one can touch those, we cannot do anything, but what we have to work on is this piece, which we do not have. How do I determine f of x plus h? So f of x plus h will be, before I put it in here, I have to find it. So what would you write? Yes. Awesome. Very good. Awesome. Perfect. Yes, in this case, because there is no number in front, there is no negative sign, I can write it without parentheses, or with parentheses, it's the same thing. Very good. So far, so good. And now, remember, we cannot distribute 3. We must square first. So what do I get when I square x plus h? That was the first handout of the class. Plus x plus h plus 5, and only now I can distribute 3x squared plus 6xh plus 3h squared plus x plus h plus 5. Now all this will replace this piece. All this will replace this. So now I can continue. Let's stop for a moment and refresh our memory on something very important. What has to happen here? Two things have to happen. The first thing that has to happen is
Get rid of the ones without H.
everything without h has to go away from the top. Somehow they have to cancel out. If they don't, I made an error somewhere. What is the second thing that has to happen? That one, yes, must go away, must simplify somehow. Correct. Very good. So keep those in mind. So I'm going to copy 3x squared plus 6xh plus 3h squared plus x plus h plus 5. I reach this point right now, and I have to distribute -1 to all 3 terms. So please tell me what to write next.
Minus 3x squared.
Perfect. If I distribute, I have to distribute to all, or I put parentheses. So minus x minus 5. So we either put parentheses and distribute later. I'm too lazy to write this one more time, but if you want me to, I will. I'm kidding. Of course I will if you want me to. Divided by h. So again, look here for one more time. So this is negative that has to be distributed to all terms, not just to the first one. Or we write parentheses with minus in front of 3x squared plus x plus 5 and distribute later. Negative 3x squared, negative x, and negative 5. Is this good enough, everyone? Okay, so as expected, negative 3x squared with positive 3x squared, negative x with positive x, and negative 5 with positive 5. So what I was expecting to happen, it did, the first step. So all terms without h did cancel out. So how many terms are left? It's very important to take it easy and identify how many terms. Yes, so when I pull out what? When I pull out, very good, because that's the next thing that has to happen. How many terms will I have to write in parentheses? Exactly how many? Yes. That's why I asked from the very beginning how many terms are left. So I need 3 terms in parentheses. Please dictate. I agree. I completely agree. Plus 1 indeed. That's the reason why I asked how many terms, so we don't make an error and just write 2 instead of 3. So the simplified form is 6x plus 3h plus 1. Do you think we need another example with a difference quotient? It's okay if you say yes. If you say no, I'll move on.
Yeah.
Any particular type of function or the same?
Anything.
Okay, do you want a rational function? Do you want a quadratic function? I didn't write it yet. That was cute. You will see rational functions in my math lab as well. Sure. So f of x equals, this is problem 90. F of x equals 1 over 2x. Okay, 1 over 2x. We are asked to find the difference quotient. The difference quotient will be given to you, which is f of x plus h. Oops. Yes, this formula, yes, it will be given to you. You don't have to memorize it. My calculus students have to, but not you and not my pre-calc students. They don't. It will be given. Now, I don't want you to forget to review. You didn't ask any questions today, but I'm hoping that you solved all these problems and got the answers that were here, because a problem like this will be on the test. And it's not in my math lab, as you know. Okay, so can anyone give us what is the piece we don't have? Which of the 3 pieces we don't have? We don't have f of x plus h. So now please tell me what to write. Yes? 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 Awesome. That's all I needed. Very good. Well done. Okay. So now what will be my next step? Say it again. You're on the right track, I'm sure.
Get rid of the fraction.
Right. But I can multiply. So when I subtract fractions, what do I need to find first? Yes, we've done that with equations. Very good. So what is the least common denominator? The least common denominator is? How many different factors we see here?
2x. 2x plus 8.
So, but I cannot repeat the factor. I mean, I can, but that will not be the least common denominator. So, how many different factors we see? Say it louder. I think I heard it. How many different factors we see? I know you know. How many? 2 is a factor, x is a factor, and x plus h is a factor. How many different factors we have? Good. So 2x, x plus h, right? They're all different factors. They have nothing in common. 2 has nothing in common with x and x plus h. X has nothing in common with 2 and x plus h, and x plus h is all by itself. Good. Adjustments, please.
What happens to the 2 in front of the 2 parentheses x plus?
Nothing. It's a factor. But it's present in both. And it's the same factor. I cannot count it twice. Unless it has power 2. But it does not have power 2. So 2 times x plus h was multiplied by? We forgot what we did last week or 2 weeks ago. 2 times x plus h was multiplied by what to get 2x x plus h?
1. It's like 1.
So what is the extra factor that is not here, but it's here? Okay, thank you. What is the extra factor that is not here, but it's here? Thank you. Same thing. That's how we add fractions, right? Or subtract fractions. Good. Can anyone give us the top? Yes? No? We have to be careful. I completely agree with that. Well done. Good. So what did we expect to happen on in the first step? The terms without h must. Good. Do they? Good. So now how do I divide a fraction by another fraction? So I copy the fraction from the top. And what do I do now? How do we divide two fractions? Multiply by? Good. Which is? Very good. So what has to happen as a second condition? I do not cross multiply unless it's a proportion. Yes, I will simplify the h by h. And that's what has to happen. That's the second thing that has to happen. The h in the denominator, like before, must go away. So this is the final simplified form of the difference quotient. Nothing new. We knew how to add and subtract fractions from rational equations. We know how to find least common denominators. We know how to find the adjustments for the top. We know how to distribute -1 to x and -1 to h. We know how to simplify. Good. Do you think we need another?
Yeah.
What type of function? Okay. So let's say g of x this time equals 1 over x minus 1. So we have the difference quotient, and this time is g of x plus h minus g of x divided by h. What type of function is this? Very good, awesome. It's a rational function. Can anyone give us g of x plus h? Perfect. Yes? Yes? Very good. -1 over x minus 1 divided by h. Perfect. Well done. What do I need to do next? Very good. Awesome. What is the least common denominator of these two? How many different factors we see? Two different factors. Therefore, both have to be in the least common denominator. Good. Can anyone dictate? What do you think? What will you write? I know it looks different, but this is no different from 1/2 minus 1/3. The least common denominator is the product of the two. I need a 3 here and a 2 here, so it's 3 minus 2, which is 1/6. It's no different. It's exactly the same. It just looks different. It's painful to the eye. When I look here, I see a 2 and a 3, and here I see all sorts of letters. But it's the same idea. So we never multiply denominators. The factors in the denominators have to stay as factors. So what do I write? It must be a product. Very good. That's the product. There are two factors. You cannot factor this in any way, shape, or form. And you cannot factor this in any way, shape, or form, like 2 and 3. Good. And the top will become never. Very good. Very good. So please do not automatically copy something from the top. You have to ask yourselves this question one more time. I had this factor initially, but now I have these factors. Which is the additional factor? Well, obviously x minus 1, so I need x minus 1. What did I have initially? This one. So there is an additional one. I multiply the denominator by this. I have to multiply the numerator by the same quantity. Is that clear? So this is what we did with this. Just that this is it looks more difficult. Good. So what is the top? Can anyone give us the top? Very good. Very good. Negative 1 times x, negative 1 times h, negative 1 times negative 1. Very good. Two things have to happen every time I calculate or determine or simplify the difference quotient. What is the first thing? What? All terms without h must go away. If they don't, I have an error somewhere. Okay, do they? Negative x, no, negative h, yes, there is a remainder from the top. Good. So then the top is negative h over x plus h minus 1 times x minus 1 multiplied by? Yes? Awesome. Great job. So now I have h goes away, and the simplified form is negative 1 over x plus h minus 1 times x minus 1. So please practice this, and please come back on Tuesday and say, I worked on these and I got them or I didn't. Okay, one other topic in this section is piecewise defined functions. Piecewise defined functions. What on earth is that? Well, here's an example. I know nothing about the new text code. I don't know how they change it. If they change it, I know nothing. So in the past, I can only talk about the past. I'm making up numbers now. For someone with a gross income of between 0 and 40,000, let's say that person pays 10% in taxes. For someone making between 40,000 and 80,000, pays 20% in taxes. For someone between 80 and 120, pays 25% in taxes. This is a piecewise defined function. What does it mean? For certain values of x, a certain function. For other values of x, a different function. For other values of x, a different function. That's a piecewise defined function. Here's another example. I know this is not valid anymore, but in the past, not everyone had an unlimited cellular phone coverage, right? Or unlimited minutes. So in the past, I know maybe you're too young to remember, but I do remember between a 0 and 1,000 minutes, we used to pay 20 bucks. If we used between 1,000 and 3,000, we used to pay 30 bucks, whatever. So this is another piecewise defined function. So on page 252, I'm going to copy a function that is a piecewise defined function. And I will ask you, how many pieces does it have? How many pieces does this function have? Let me check if I copied it. Sometimes I copy from one problem and part of another problem. Yes, I think I copied it correctly. Doesn't matter really. So this is problem 69 on page 252. I like to copy some problems from your book so you can reference back and go back and work on those. Okay, how many pieces does this function have? Yes, it has this piece with this function, this piece with this function, and this piece with this function. One more time, what this means is that they cannot overlap. For particular x values, there is one function that doesn't go anywhere, doesn't go this way. In the middle, we're going to have another function that does not overlap this way or this way. It's a totally different function. It stays within those limits. And the third piece will be another function that will not overlap or go that way. It will only be on this particular piece of x values. So we see three pieces here. First thing that I would like to do is change this into the interval notation. What is the first thing we always think of when we are asked to graph a function? The question here is asking us to graph this. What is the first thing that we need to determine? The domain. No matter what function, if you remember, every time we graph the function, the first thought must be domain. I don't know where this function exists, for which x values, till I find its domain first. And then I will start the table. Good. Can anyone identify this in interval notation for us? Perfect. With? Parenthesis, right? There is no equal symbol. Good. Awesome. What about the middle one? Good. And symbols? Very good. Awesome. We understand this? Yes? Everyone? Okay. What about this? Say it again. Very good. Awesome. 0 to infinity with the bracket because of the equal symbol. Do we understand these three symbols? Intervals. Okay. Now I'm looking to find the domain first. So I have everything between negative infinity and -4, not -4, but then I have -4 to 0, not 0, but then I have 0 to infinity. Can anyone identify the domain of this function? Do you all agree that everything is there and there is nothing missing? Yes? Yes, everyone? Okay. So my next step after I identify the domain will be the table of ordered pairs. Negative infinity to infinity. Let's go back to the function and I'm going to ask a different question now. Which x values must be in the table? We like them or not, it doesn't matter. They must be in the table. Which ones?
-4.
And
0.
why? Awesome. Why? Why do I need -4 and 0? Correct, but also because they are called thresholds, right? This piece stops at -4, where another piece starts that stops at 0, where another piece starts. So they must be in the chart, -4 and 0. Other x values as well, but not yet, in a moment. I know you're probably asking yourselves, and if you bear with me, it's going to be very clear. You're asking yourselves, I'm sure, why is she doing this? Why is this here? Because this is clear enough. Why is she doing this? For two reasons. One, to determine the domain easier, I think. And the second one is crucial. So, see, I have a parenthesis going this way at -4, but also a bracket going this way at -4. These are the symbols in that particular order that I will present exactly under -4. And they are touching. These two symbols, bear with me, I'll explain what I'm doing. So bear with me and write those two symbols under -4. Can anyone give us the symbols that I have to graph or present under 0? Although we still don't know why we're doing this just yet. In a blink, it will, yes. So a parenthesis open this way, and the bracket open that way. And it's exactly the same thing in this case. It doesn't always happen, but it's the same thing for both numbers now. The next step is an overkill, but please bear with me. Which function do I have to use for x values between -infinity and -4? And you can say it's right there under your nose. True. I want to put it here, though. This is not x. Correct. Very good. Awesome. Now, between -4 and 0, although it's right there under my nose, I would like to write it. Which function are we using for x values between -4 and 0? Do you all agree with -x? Is it a yes? Perfect. What function will I be using for x values between 0 and infinity? Very good. No, I wasn't doing this just to move the page over. No, but because it's easier to have them right here. Good. So now, this is a linear function. I'm going to choose -5. So when x is -5, how much is y? Perfect. Now I'm going to do something that you would have to disagree with. I'm still going to do it, but you should be appalled. I wanted to ask you, when x is -4, how much is y? And you should say, wait a minute. You cannot plug in -4 in this function. You can plug in -4 in this function, because that's what we are given. -4 pertains to this. -4 does not pertain to that, because there is no -4 here. -4 is here. But if you don't plug in -4, then I will have to ask you to plug in -4, the first number on this side, -4.0000000000001. So bear with me and plug in -4. When x is -4, how much is y? And I put that number right here inside the parenthesis. I'll explain in a moment. It will become very clear, though. Okay, now -4 on this side. And then you will have to say, yes, you can. You're allowed to plug in -4 in this function. How much do I get when I plug in -4 here? Very good. Right here inside of the bracket. Now, please plug in 0 in this function. Although we're not allowed to. And I'm going to write 0 inside the parenthesis. And now please plug in 0 in this function and tell me what you get. Good. Well, let's plug in at least one more. Although we know how to graph x squared, let's see, we plug in one more. What do I get? Perfect. Awesome. That's all I need. Now we'll explain those symbols. Right now when we plot the ordered pairs. So from left to right, please give me the first ordered pair. The first ordered pair from left to right. No, that's not the point.
Negative infinity and negative 4.
No. The first ordered pair is -5 for x, 0 for y. We cannot say 0 comma -5. It has to be -5 comma 0, correct? X is the independent variable, y is the dependent variable. So -5 comma 0. Are you with me, everyone? So here it is. The next ordered pair, please. But now, what type of point will this be? Because I really wasn't allowed to plug in -4. What type of point will be -4 comma 0? Yes, exactly. That's the reason why I forced you in a way to plug in -4 in the left function, although we were not allowed to. Because if I stop anywhere else, then I miss infinitely many real numbers, and we cannot do that. So we have to stop at -4 precisely. So this is the graph of this function between -infinity and -4. No one can do anything else, and you cannot extend it this way. We're done. Now we are in the middle. What is the next ordered pair that I have to plot? Very good. Awesome. What type of point is this? Because of the bracket. This point becomes a full point, which is right here. Now 0 comma 0, what type of point is that? Correct. And now I am done with the middle part. I graphed -x between -4 and 0. No one can extend this graph to the left or to the right. It will be a terrible mistake. I'm done with the first two. I reach the third one. Point 0 comma 0 is the next. Oh well, it happens that one ended and this one starts, so I have to fill it in. And then 1 comma 1. And this is a quadratic function. It has to be graphed as a quadratic function, not a straight line. We're going to revisit quadratic functions in chapter 3. So this is the piecewise defined function, the graph of the piecewise defined function. I'm going to ask you to find the range. Remember, imagine you cut it with the horizontal lines from the smallest y value till the largest y value. What is the range?
0 to
Do you all agree with 0 to infinity? Let's choose another.
You said the largest value.
The largest y value is 0, and the smallest y value is 0, and the largest is infinity. My pleasure. Okay, so I know this is not enough, it's just one example. But now, I just want to come back for a second and explain those symbols one more time. The parenthesis will give us an open point. The bracket will give us a full point. If it happens that these two numbers, which is not the case here, if it happens for them to be the same, then I will have, like here, both numbers the same, I will have a full point. But since in this case they're not the same, this point on the right, because of the bracket, will be a full point. But this on the left, because it has a parenthesis, will be an open point. Now, let me show you the method in the book. If you prefer it, I completely accept it. I honestly think is something I would never personally do or present in class. But if you think that this is the correct way, if you feel that it's better for you, they present two different charts, one chart for this graph and one chart for this graph. I think it's way more difficult than what I'm showing you, but feel free to use any method you like. I think this is more difficult to put together, but maybe not for everyone. So feel free to use that method if you like it. Okay, so let's look at another one, like for example, 67. Same page. We have f of x equals 1/2 x squared for x less than 1. And the other is 2x minus 1 for x greater than or equal to 1. And then we can continue with 2.3 and 2.4. Okay. Now I'm looking at this function. I'm asking myself, what is it? And the answer is a piecewise defined function. How many branches or how many pieces does it have? 2. And remember, we have to be very careful. We cannot graph something like this. This is not going to be a function, right? So each function is on its piece of the real line, and they cannot overlap. Good. I'm going to continue with finding the domain by changing these two in interval notation. I also need those symbols under which number? The only number that will get 2 symbols under it. You have to look at the function. 1, indeed. 1 is the threshold. Good. So can anyone give us the interval notation for this? Very good, with a parenthesis, correct? Good. What about this one? Bracket 1 to infinity. So what will you say about the domain of this function? Do you all agree that we have everything? The function has everything? From negative infinity to 1, not 1, but 1 is here, and everything from 1 to infinity. Agreed? Yes? Okay, now we can start the chart. Negative infinity to infinity. You already told me that 1 has to be in the table, and also 0. 0 will always be in the table, in this case also 1. Can you dictate the symbols under 1, assuming you like the method? Parenthesis facing left and a bracket touching facing right. Now please tell me which function. I know it's an overkill, but I prefer having them on top of the table. Which function will we be using for x values between negative infinity and 1? Awesome. Which function will we be using between 1 and infinity? Yes. The other reason why I'm doing this is because sometimes the branches are not presented in correct order. Okay, you will see sometimes they will put it the reversed way. And here we have to put them in the correct order. So that's another reason why I want to have those functions at the top. Good. So let's say because it's x squared, I'm going to say also negative 2. Let's see what we have. So let's plug in negative 2 in the function. So negative 2 squared is 4 divided by 2. Very good. Please plug in 0. Very good. Please plug in 1, and you should say no, 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 no. I won't do that. But then I will say please plug in, otherwise you have to plug in 0.99999999999. So I get 1/2 right here inside the parenthesis. Let's plug in 1, and we get 1. Let's plug in 2, and we get, very good. Do we all agree with the ordered pairs so far? Yes? Okay, from left to right, please give me the first ordered pair that I need to plot. Do you all agree with negative 2, 2? Very good. Negative 2, 2. 1, 2, 1, 2, right here. The next ordered pair is? Very good. Next ordered pair is? What type of point will be 1, comma 1/2? Do you all agree that this will be an open point? Why? Because of the parenthesis. Why? Because there is no x equals 1 in here. So remember, this is a quadratic function, and here's the graph. You cannot extend it beyond 1. This function is only presented for x values between negative infinity and 1. Between negative infinity and 1. And no one can extend it anywhere else. The next ordered pair in line will be 1, 1. Kind of close, but they are not touching. One is at 1, comma 0.5, and the other one is at 1, comma 1. And then 2, comma 3. As you notice, the line 2x minus 1 cannot be extended this way. The line 2x minus 1 is only for x values between 1 and infinity. If I were to extend the line, this would not be a function anymore. Look. By the vertical line test, it will not be a function. Okay, so also I would like to determine the range for this function from the smallest y value till the largest y value, 0 to infinity. Do you think we understood the idea of piecewise defined functions, how to graph them? Yes? Would you look at a few more examples and then come back on Tuesday and say, here's another, let's look at it? Do you think we need another one right now, or can I move on to 2, 3, and 2, 4 together? Oh. 2, 3, and 2, 4 deal with the same thing, which is lines. They're both a review. However, we will look at all different types of problems. And then for the test, what is the remaining section is 2.5. Okay, so these are the last 3 sections before test 1. And the previous test that I gave you covers everything from all chapter 1 and sections 2.1 through 2.5. Okay, ready? Okay, so we know we have several types of lines. This is one. This is the second one. This is the third. And this is the fourth. Types of lines. Now, does anyone remember what is the definition of the slope of a line given 2 points? Given 2 points or 2 ordered pairs. Anyone remembers? Yes. You're way ahead of me, like always. That's awesome. Yes. Yes. Very good. So this is the slope. Good. So now, can anyone tell us what is this line? Assuming my graph is accurate. It's a horizontal line. What will be the slope of this line?
0.
Perfect. What type of line is this?
Vertical.
So what will be the slope of this line? Very good. The vertical line has no slope. It's undefined. Now, for any line that comes from negative values to positive values, what type of slope will that be? Very good. So this is the case with the positive slope, and obviously when it comes from positive values and goes to negative values, this is not what we want to see, but depends on the problem. If it's about fever, you know, you want it to decrease. If it's about income, I'm sure you want it to increase, right? So this is m less than 0. It's a line with a slope that is negative. Perfect. Okay. We have 2 equations of the line. 2 equations of the line. One of them is slope, which I like to write y-intercept, not just slope-intercept, so it's clear. And the other one is point slope form. The slope-intercept form is, you already told me, y equals. Awesome. Where b is an ordered pair. B is an ordered pair. 0, comma b, the y-intercept, 0, comma b. The point slope form is y minus y1 equals the slope times x minus x1. This was done a long time ago, but I wanted to go back and refresh our memory before we look at problems. 2 other things. Lines can be parallel and they can be perpendicular. So one more time, this is a slope-intercept form, y equals mx plus b, where this number comes from an ordered pair, that is the y-intercept, 0, comma, a number. Here, this definition works, or this form works for any point, including for this one. But it can be any other. Okay, parallel lines. These two lines are parallel. M1 is the slope of the first line, and M2 is the slope of the second line. What is the relationship between these two slopes if the lines are parallel indeed? They have to be the same. M1 equals M2. Now let's imagine that we have two lines that are perpendicular. Two lines are perpendicular if they form 4 90-degree angles. Let's say the first one of the lines has slope M1 and the second one M2. If the lines are perpendicular, what will be the relationship between those two slopes? Negative multiplicative inverse. I don't remember it like this because it's a mouthful. M1 equals the negative multiplicative inverse of M2. Instead, I cross multiply. So I say M1 times M2 equals -1. So in short, I say two lines that are perpendicular have to have the product of the slopes -1. But it's the same thing. It doesn't matter. Whatever you're used to, don't change it if you don't want to. So you either say M1 equals the negative multiplicative inverse of M2,